I will be sharing the screen. Oh,
Hello?
Yeah, I got some troubles connecting to BlueJeans, but I'll start anyway.
Okay. I mean, if it doesn't work, I guess worst comes to worst. I don't know if you have some sort of an app that can like record a video
Oh,
of your like screen or something, and
it's
then
fine. Can you
post
see
it.
my? Can you see
It was
my?
no, it was there and then it went away. Up now it's coming up again.
Can you see my screen?
Now I see it.
Well, anyway, let's start it. In today's walkthrough, we'll be reading the code of a MonClient and the monitor. As we already know, the MonClient is a client of monitor, and in Ceph, monitor is serving for multiple purposes, like publishing the status of a cluster and to manipulate them. To be specific, status includes the cluster logging, authentication, authorization, and the publishing of a PG status, OC map, and PG map, and the state of the monitor itself, namely monitor map. Quite a few of the status have the prefix of the postfix of a map, and all of them are versioned internally. As a client of a monitor, the monitor client apparently exposed the status to the Rails client. In this walkthrough, we'll start with a command we use in daily basis, Ceph-S. As you can see in my Emacs, is it clear, and the phone is fine for you, David? Okay.
Looks good.
Cool. As you might know that Ceph-S is actually an alias of Ceph status. And let's look for the status. We go to the chart arcs. But before any command is executed by the client wants to make sure the semantics, the syntax of and the argument is same, and it also want to make sure that the argument is the command is valid. So it wants to send the command to get the descriptions of all the commands that are available in this cluster. The command is named get command descriptions. Apparently, the command will go to the monitor. Underlying the JSON command, so actually, let's go to the implementation of a JSON client. The command is a method exposed by the Ceph path. Find a path JSON command. It's called send command retry. In turn calls send command. By default, send command will send a command to monitor. and it's also able to send a command to OC and other parties. In this case, it will be a monitor. So it will be the MonClient method in cluster. Actually, it's the method of Redis Python binding. My MonClient. MonClient on, if I recall correctly, will be Redis mon command, but we don't specify a target, so it will be Redis mon command. It's a method in Redis C binding. Go to the libRedis. And find its binding. Again, we expose the C API using, expose C API using the C interface. So let's go to the monk command. We expose the async message calls using the synchronized interface. And here we are. As you can see, this is the instance of MonClient, and the method name is start MonClient command. It accepts a vector of commands. The first argument would be that get command description, and if there are some more argument, it will be packed into this vector. And if you want to send some binary info, it will be in buffer list. If the return value would be some buffer, it will be stuffed into out buffer list. And the output string will be put into out S. Once it's done, unfinished callback will be called. Let's dive into the start mon command. Here it is. There's a pattern in MonClient. When we run a given request, we will wrap into a structure so it can be replayed if we are not connected to the cluster or we fail to get the reply in time. In this case, the request will be wrapped into mon command structure and put it into the mon command map and hook it up with a callback if we specify a timeout. This map will be, the command in this map will be played once we get to the connect to the cluster, to the command. There's always two cases in MonClient. One is that we are not connected. The other is apparently we are connected. We tell this by looking at the active connection. If we have an active connection, we are connected. Actually. Otherwise, we need to connect to the cluster by authenticating ourselves and get authorized, so we can get access to the service we want to access. But for most we want to get to the access to the monitor. Where if everything goes fine, we will send the command in the mon command message. We'll put this aside, put the connection step aside at this moment. I'll come back later. Where we send a message to the monitor. And if we don't have a connection, we will push the message to the waiting list and resend it once we get connected. Let's switch back to the connecting steps. The monitors are named with ranks. If we don't specify one, which implies that we can connect any of the monitors listed in the initial monitor map, we read from either from the configuration, or we look them up in the SRV record, or we get them from the command line. Let's look at the connections. In this case, we don't specify any certain monitor. Since we don't specify any certain monitor, we want to be fast, and we try to connect to all the not really all of them, but quite a few of them to get connected ASAP. Here we connect to multiple monitors in parallel. The number of the parallel is specified in the configuration named the MonClient parallel, and we get connected to them. And when we connect to the monitor, we send a hello to them. Start is the method of another class, because we want to abstract the details of the authentication out and capsule them in another class named the Mon connection. Where we start the negotiation, because we have no idea what authentication method we'll be using, because currently Ceph support two authentication methods. One is the Ceph, another is none. None is just accept whatever we have and always get the client authenticated and authorized. Now we'll be talking about the Ceph authentication method. But we won't get into the detail of the Ceph. I will send out the link to a talk which details the authentication and authorization steps used by Ceph. We will just take it for granted that the client will get authorized, and when we have a final author reply from the monitor, which marks the end of the authentication steps. if if the authentication does not reply yet again, it marks the end of the authentication, and the Monk connection will consider the Monk connection get authorized. Whichever connection gets the non yet again return value, it wins, and we will close other Monk connection. Let's check. Down. Here. It's the yes. If we don't get the E again, we will we will we will take the connection current connection as a winner and save it to active connection and clear up the pending connection, which for the all the Monk connections that is running in parallel, and finish the hunting and store the authentication and the authentication structure and notify all the waiters that are waiting for the connection to monitor. In the case of the MonClient, commands, we send the pending commands we just sent. Here we are coming back to the send command method. And the command is sent to the monitor. Let's go to the monitor side. In monitor.cc is actually a facade of the monitor. It is the global entry of the services exposed by monitor. Just like other parties that is interested in the message, it is called the method of MS dispatch. Okay, dispatch first. And it will dispatch the method, the request by its type. In this case, it will be MonClient. The type ID is method MonClient, and will handle it by the monitor class by itself. Otherwise, it could be dispatched to other services hosts. We'll come back to later. In this case, it will be a handle command. We will pass the command structure to the adjacent structure. First command would be get command description. It's funny that all of the commands are listed in MonClient commands with their description and the usage. But The first one, the get command description is not listed because it is the entry to this, is a key to this the command description. Here this command is handled, and the monitor will reply the request with all the command description it is available to the cluster. It includes the command available in the monitor from normal monitor, but also includes the command from the manager. The command from monitor is listed in the leader mon command, which is constructed and initialized in the constructor of this class. And this is actually the command list here. And to the commands from the manager side, the monitor gets them from the manager service. When the manager is up and running, it will send all the command description it has. It has send it with a beacon to the monitor, and it will be handled by the manager monitor. Let's go to the monitor. And it is, or you can go to the details of this later on. And it is up, actually it will be updated by the Texas, and the manager monitor will catch it up in the update from Texas. You can go to this part later on. But what we have is the description of the command description. Let's back to the thing. Once we have the description of the command, we will validate the signature against the command description and send the command itself to the monitor. This time we won't need to go through the steps to get the client authenticated and authorized. And again, the command will go to the monitor. And this time it will be handled here. A status will dash -s will include the state of overall or health status of the cluster. The monitor will query the status of different services exposed by different services. It includes the state of the monitor map, hosting map, PG map, FSM map, previously known as the MDX map, and also manager map, and other services. For example, the ones known by the manager, because currently manager hosts half of the services that will do. Where the service, for example, the RGW is holding their status to manager, and the manager is responsible for collecting the status from these services, and then digest to the monitor. That's where the service map is collected. When we get the cluster status, we'll send it back to the monitor client. So far, we went through the code path for reading the status from a cluster. Any questions so far? Okay.
Yeah, actually, it's kind of, if you go back to where you had all the different maps, maybe it's in the PG map. I forget. Anyway, it's probably not a big deal. I was looking at the pool stats, and maybe they're in the PG map. So I was looking at the code where the OSD is pushing. Okay, because I wasn't seeing the pool stats, but I forgot where they were stored. So yeah, like I was looking at the OSD code that's publishing the pool stats from the primary OSD for the primary PGs of a given OSD and sending it to the monitor. So, okay, yeah.
Actually, PG map is a little bit different than the other maps because before, if I recall correctly, before Mimic, we are collecting the PG stats in monitor, but in Mimic, we are using the manager for collecting the PG stats, and OSD, the primary OSDs are sending their PG stats to manager instead of to monitor. That's why the PG map comes from the PG stats monitor. But when it's before it's upgraded to Mimic, this OT will send it to the PG stats to both of them.
Oh, okay.
To monitor and also to manager.
Okay. All right. Anyway, that's not here nor there for what you're going over. But thanks.
Yeah, we can go. Yeah, we can go to detail if the time permits because we are running out of time. The reading code path is a little bit simpler, and the write path is a little complicated because it involves the access in monitor. If we want to update the status of the cluster, for example, if we want to update the configuration in the cluster, we also need to set for example, if we want to set the configuration, we will go to the go through the steps of here. And in this case, the monitor will dispatch this request to the configure monitor.
But this is new in Mimic, right?
Yes, it's a new Mimic. It's a new feature. Centralized configuration management in Mimic. It is served by this new monitor. And the beauty of this implement is that it's very simple. And let's go to the we should go to the dispatch method itself. And all the services are inherited from the Paxos service. We will go to the Paxos service first. Method name, right? method looks complicated, but what it does is to to handle the command to see if a command is a read-only command, it can be processed by any of the monitors. No matter it's the peon or a leader. The peon can serve the read request, but only the leader is able to write to the cluster. The in process Linux, if the cluster is not readable, we will be waiting for it. We'll come back to this later. In our case, it will be config monitor. And will be man config monitor. And apparently, if we want to set a config entry, it will be a write operation. It is not listed here. And the read request is handled here. So it will return false. So it's not the easy path. And if it's not a leader, the current class, the current monitor is not a leader. Peon will forward the request to the leader, wrap it around with the M forward request. And on the leader side, it will unpack the request and go through the same route to see if it is a leader, and it will process it. And if it's a leader, and currently the cluster is writable, we'll try to update the status of the cluster. Thank you. This is back to the monitor, where we pass the commands and normalize the key, so it can be set in the rockdb properly. We're still normalizing the key. Here's the interesting part. We are putting the updated key in the map, which named the pending. The key of the pending is a key, and the value of the map is the value of the setting. But how would we persist this change to the cluster and to update the other monitors, and eventually broadcast this news to the interested parts? So on. And we'll go to the update label. We will sanitize the pending map before going further, and we'll propose a change to the column of the monitors right away. Need to immediately switch back to the color of this function. Get back. Okay, here it is. We're checking the this member variable, and it turns out we need to send the proposal right away. Let's check out the proposed pending. we note that the two of them because we are in the packet service, we need to check out this message. Firstly, we persist a change in the cluster. We need to encode them. Only the service knows how we want to encode the change. In this case, it's the map. So we encode it as a transaction. In this database world, it will be a write-ahead log. Once we get it ready, it is stored in the input parameter. And we also piggyback quite a few metadata changes along with the data changes. Here we want to propose a package and send it over to Paxos to get it applied. Once it's done, we will call this. We won't go to details of this. Let's go to Paxos. And in this case, everything goes fine. We will propose a pending. It knows we are in Paxos, so we'll go to this message. We are encoding the proposed change into the buffer list, and the buffer list will be sent to begin. The begin means a little bit general, but what it means is we're beginning a proposal. We send the news to other monitors in this cluster. Only the leader can propose a change, but it wants to get the green light from his peers before it moves forward and gets the change committed. All the proposals are versioned, and it comes with a proposed number. And each change from Paxos point of view is simply a value, and it's opaque from its in his eyes. Apparently, there is only one monitor. It will be getting committed right away, and there's a multiple of them. It will get the vote from them, where we send a message to its peers. On the Pure side, we will see it will handle the OP begin. On the Pure side, it will check if it can accept it. But every proposal comes with a proposal number. Here is a short for proposal number. If it's the current proposal number is less than one, the accepted one, it will just drop it instead of reply to it. If it is accepted, it will send the accept message to the leader, and also it will fetch the new value comes along with the request, the proposed, so it can be replaced once it gets committed. Currently, it will just store it. You can see the transaction is actually applied, but it just stored it with the latest commit message. See? and here. So it's stored, but the log is not plate before it gets the note from the leader. So on the leader side, once you get the OP depth, you handle it. If if the full column has accepted the all the peons have accept the proposal, it will commit the proposed change by committing. By the means of committed, it will play the log to apply the change we just proposed. In our case, it will change the config map. Let's put it this way. Here we'll do the transaction in the RocksDB store. Once it gets committed, it will call commit finish. By the time the change has been persisted in the disk. It will also update the metadata and update its peon, because the peon they only stores the transaction, but they didn't get a chance to play it. When they get the message of OP commit, it will play it and update the hosted service. But let's focus on the leader side. Once the change is persisted to the disk, it will refresh the interested service. Fresh. Here is the interesting part. In the doFresh method, it will call refresh from Paxos. And it will update all the services. Refresh. And each service is supposed to override the method of update from Paxos, which means there's a new change from the cluster. You need to be aware of. In our case, let's get back to the config monitor. So the change it's just proposed get committed, and it needs to check it out. Where it read the change from the underlying store and iterate over it, sanitize it, and update the local config map. And also, it will update its subscribers, because in monitor there are quite a lot of services that the client want to be updated. If there's any subscriber interest in the config change, it will get notified. Yeah. You might know that mconfig is actually processed by MonClient. Yes. So the MonClient will get updated by the change of the chain of the configuration. Because instead we want to avoid a single point failure. That's why we have multiple instances of monitors. But what if a monitor is a pure monitor is hosting a stale data and fail to get the update from its leader? We have a machinery named Listen to address this problem. This is a different one. When this is the method we just checked, named the commit is finished. When the commit is finished, and there are multiple instances of a cluster, we want to update the list time. A list is something like the label in your on the food you in your local grocery store, which where there's a print label like best used before or used before. Same applies to the status of a cluster. If a status is too old, it's very likely it's wrong. So we have them labeled with the expire time. When the status is expired, the peon or the peon will restart the election, but it get updated before it expires. Everything will be fine, and the cluster is still readable. In the case of the configuration change, the list is extended, and the news is broadcast to the peon. On the peon side, the extended list message is handled so that its list message is extended, and the timeout is cancelled. Otherwise, it will start another round of election. That's why if we take the compaction underlying RFDB compaction takes too long, and the leader fails to broadcast a new release message, the peon will start election. And when the cluster is not readable, which means the request from the MonClient will be queued in the queue and will not be replied, which means that the whole cluster is in the read-only status. See what happens if the cluster or the timeout fires. Every time we set a timeout, we actually set a timeout. It's the list timeout. This instance of monitor bootstrap. By bootstrapping, it means that the cluster, the monitor is just up and running, and it want to join the quorum. By joining the quorum, it will try to start a new election and send the probing message to its to its peers. The probe message is the first step to the election. Okay, I guess that's all of the code walkthrough. We could go to the details in the next walkthrough. You would like any questions so far?
Nope.
Okay, cool. Have a good night.
All right, good night.
Good night. Thanks.